Now let's quickly write the binary search based code for finding the square root of a number in JavaScript. So here I have created the new file, and I have written the class, and I have declared the new function as well, and I have written the code for calling that specific function as well, so that we can quickly get into the implementation part. So here, since we are going to use binary searching, let me just define the start with 0, and let me just define end with the number itself. Now along with that, let me also define one variable middle, and I will be initializing it with -1. Now what I will do, as long as the start is less than or equal to end, we will simply calculate the middle. Middle is nothing but math.floor of start plus end divided by 2. Once we get this middle, if at all the middle square, which is nothing but middle into middle, if it is equal to whatever the number that we have got, in this case the square of the middle is actually giving us the number. That means this middle itself is the square root of this number, right? So here we will simply return middle itself. If this is not the case, that means if at all the squared value of the middle is greater than the number that we have got, in that case the squared value of middle is greater than the number that we have got. That means the square root of the number will be somewhere less than whatever the middle that we have got, right? So we need to continue the search the values from whatever the start that we have till the middle -1 that we have. So to continue that, I will update this end with middle -1. If this is not the case, the other scenario will be the squared value of this middle is less than whatever the number that we have got. That means this actual square root of the number could be greater than whatever the middle that we have. So in that case, we will update the start with middle plus 1. Okay, if at all the number that we have got does not have a proper square root, let's just say the input that I'm passing is 4, right? 4 is nothing but 2 square, so the square root of 4 is nothing but 2. It has a proper square root. But if the number that I'm passing is 8 does not have a proper square root, right? The actual square root of it will be something like 2.8, something like that. In that case, what we need to do, we need to return 2 itself. So to handle the numbers which does not have proper square root, we will simply return start -1 in the end. This start will be having the value, will have one value greater than what is the closest square root of that particular number. That's the reason why here we will simply return start -1 in the end. Okay, so this is to handle the values which does not have a whole square root value. Okay, that's it. Now let's just test this scenario, and here first let's just test the the numbers which have a proper square root. So 9 has square root of 3, right? So if I run this now, the output is okay. Here the function that I need to call is square root using binary search. So if I run this right now, the output is 3. Okay, 3 square is 9. Okay, so to test other scenarios, let's just say 25. 25 is nothing but 5 square, right? So 5 is the output. So that is what we have got. Let's just say I'm passing something 29. 29 is greater than 25, which is like 25 has proper square root of 5, right? So the square root of 29 will be something 5 point something. So since it doesn't have a actual square root, we will simply return 5 in this case also. See, that is what we have got. Let's just say we are passing something like 10. 10 does not have proper square root, right? The closest square root of a number is 9. It will basically give us 3 square. So 3 is the square root of 9. So square root of 10 will be something like 3 point something. So the output should be 3. So that is what we have got. And one more thing that you need to remember here is all the numbers that I have tested are basically the positive numbers. That is because in the problem statement itself, it is clearly mentioned that we will only be given positive numbers. That's the reason why I'm not testing with any negative numbers. If at all, if you want to handle the negative number scenario also, here you can simply add a check. If this number is less than 0, you can return whatever the appropriate value as per your discussion with the interviewer. Okay, so that I'm leaving up to you if at all you want to handle that case as well. Okay, so that is the effective way of finding the square root of a number using binary searching technique. If at all, if you want to check out the code using brute force approach also, I will put the problem link in the description. You can use that link and you can go to codingpal.org and you can find the solution using brute force, as well as whatever the approach that we have written as well. Okay, that's it for this one. I'll see you in the next problem.